Hello, this is Dr. Prashant and welcome back to Epidemiology lecture series. In this lecture, we will discuss about the topic epidemic. Coming to the definition, epidemic refers to an increase, often sudden increase, in the number of cases of a disease above what is normally expected in that population in that area. So basically there are two important types of epidemics. One is the common source epidemic and the other is the propagated epidemics. Let's look into each epidemic in detail. Common source epidemics are outbreaks caused by exposure of a group of persons to a common noxious influence. So in this case, the exposure can be contaminated food, water, etc. So there are three types of common source epidemics. One is the point source epidemic, and the next is the continuous epidemic, and the last one is the intermittent epidemic. So in point source epidemic, the exposure is brief, as the name suggests, point epidemic, point source. And the exposure is essentially simultaneous. So that as the exposure is very brief, the resultant cases all develop within one incubation period. The point source epidemic usually follows log normal distribution. So we all know the normal distribution, right? So let's see what is log normal distribution. If the number of cases during an epidemic were plotted over time, that is like the cases on the y-axis and the time on the x-axis, the resulting graph called an epidemic curve would typically have a steep upslope and a more gradual downslope. So let's see with the help of a diagram. So in the right side you can see the normal distribution, the bell-shaped curve. On the left side, if you can see the log normal distribution, there is a steep upslope and then a gradual downslope. And this is the example of the point source, and we know the characteristic features of point source, right? Point source come under the common source epidemic. So it is one type of common source epidemic. So in point source, all the cases develop within one incubation period because the exposure is brief and simultaneous, and it follows the log normal distribution. What does it mean? Steep upslope followed by a gradual downslope. And coming to the next type of common source epidemic, that is the continuous source epidemic. In a continuous common source outbreak, persons are exposed to the same source, but exposure is prolonged over a period of days, weeks, or longer. So in the point source epidemic, we know that the exposure is very brief, but in continuous source epidemic, the epidemic curve results from multiple exposures at different types, and because incubation periods are variable. So what does it mean? As there are multiple exposures, so for example, one exposure happened today and after 7 days another exposure happened. So these two incubation periods are different, right? So due to this, the incubation periods are variable, so there will be less distinct peak because all the cases are not falling under the one incubation period in continuous source epidemic. So the outbreak will be of longer duration because there are different incubation periods, right? So let's see the example. We know the characteristic features of continuous source epidemic. First one is multiple exposure at different time. But in point source, we see only one exposure, or we call it as a brief exposure. And the incubation periods are variable because the exposures are happening at different types. So definitely the incubation periods are different. So we see a very less distinct peak compared to the point source epidemic, and the outbreak will be of longer duration because there are multiple exposures. And now coming to the intermittent common source outbreak, it is the last type of common source outbreak, and as the name suggests, intermittent. An intermittent common source outbreak means patients are exposed to the source of the disease at irregular intervals. So if you can see the diagram, you can clearly appreciate those spaces or irregularity. And coming to the next type of epidemics, that is the propagated or progressive epidemics. In the first type, we have seen the persons are exposed to a particular source, right? But in this case, propagated. So this results from transmission, either direct or indirect, of an infectious agent from one susceptible host to another. So here the transmission happens between person to person. For example, it can be person to person transmission or vector-borne transmission or etc. So in this case, the epidemic extends over several incubation periods. So in this case also we see different incubation periods. And the upward trend at the onset of a propagated epidemic reflects an increasing number of cases in each successive time period. For example, after first epidemic, there are few cases, right? These cases will transmit the infection from them to the normal susceptible other individuals. So due to this, the number of cases increases, so that the upward trend is seen at the onset of the propagated epidemic. Consequently, what happens? There will be a decline in the number of susceptibles, because these susceptibles come in contact with the cases. So eventually the number of susceptibles decrease and they fall below a critical level, and the number of cases declines. This is how the propagated epidemic occurs. So let's see the example, and we know the features, right? The epidemic extends over a number of incubation periods, because there is a transmission of infection from case to the susceptible host at the end of each epidemic. And we clearly see generation of cases. What does it mean? At the end of each epidemic, the new cases are coming, right? So we see generation of cases in propagated epidemics. And now coming to the third type of epidemic, mixed epidemic. So mixed epidemic is nothing but it has features of both common source epidemics and propagated epidemics. So the pattern of a common source outbreak is followed by secondary person to person spread, which is nothing but the propagated epidemics. So let's see an example. A common source epidemic of shigellosis occurred among a group of 3,000 women attending a national music festival. So after this, many developed symptoms after returning home. Over the next few weeks, several state health departments detected subsequent generations of cases propagated by person-to-person transmission from festival attendees. Initially, it was common source, and all those cases, after returning back to their home, they developed symptoms, and then they started transmitting the disease to the healthy individuals or the susceptible persons. So this is the example of mixed epidemics. And now coming to the last type of epidemics, other epidemics. So when we use the word other epidemics, just see the possibilities. Like, in one case, we know that there is some exposure, like common exposure. And in second case, there is a transmission of disease from person to person. But there are some epidemics which are not common source or nor propagated from person to person. So what can be the possibility here? Let's say an example. The epidemic of Lyme disease that emerged in the northeastern United States in the late 1980s spread from deer to human by deer ticks, and the outbreak of West Nile encephalitis in the Queens section of New York City in 1999. So in this case, it was spread from birds to human by mosquitoes. So basically, it was not person to person spread. And these are the examples of other types of epidemics. On the left side, you can see transmission from birds to human through mosquitoes. And on the right side, you can see the transmission from deer through deer ticks. And on the left side of the epidemic curve, if you can observe, you can see a small arrow, right? Mosquito control began in New York City. And due to that program, the cases have started declining. If you can see the curve, there is a down slope, right? So let's see all of them in a single frame. First is a common point source epidemic. In this, the exposure is very brief and all the cases fall under the single incubation period. And the next type is the common continuous epidemic. In this, multiple exposure happens, and due to this, the duration of the outbreak is very long. And coming to the common intermittent, as the name suggests, intermittent, the exposure happens at intermittent stages, like there is irregularity. And coming to the last type of epidemic, that is propagated epidemic. So in this case, we clearly see a spike of cases after each epidemic. So the new generation of cases are coming here, right? And now coming to the next important topic, we have seen the curves now. We have seen the epidemic curves now. So based on those curves, how can we identify the period of exposure? How do we determine the period of exposure? So basically, there are 4 important steps to determine the period of exposure. Let's look into each step with an example. Let's consider an example. There is an infectious agent which is having average incubation period of 3 to 4 days, with a range from a minimum of 2 days to a maximum of 10 days. So basically, we all know incubation period is the time duration between exposure to the pathogen and the appearance of the disease symptoms. So in this example, let's break down it. Average incubation period is 4 days, and the minimum incubation period is 2 days, and the maximum incubation period is 10 days. So let's remember these 3. So coming to the step 1, identify the peak of the outbreak. And if you can see the epidemic curve below, you need to identify the peak of the outbreak. So the peak of the outbreak is on 10th day, because on the on the x-axis, you can see the dates, right? 1, 3, 5, 1, 2, 3, 5, 6, 7, 8, 9, 10, and 11. So exactly on the 10th day, you can see the peak of the outbreak. And coming to the next step, count back from the peak, from the 10th day backwards the average incubation period for disease. So what does it mean? So you have identified the peak. From peak you just count back till where? Till the average incubation period. In this example, the average incubation period was 4 days, and we have observed a peak on the 10th day. So if you go back 9, 8, 7 and 6th. So in this case, we go back from the peak till the 6th day. So we will note down the date as 6th in the step 2. And coming to the third step, identify the earliest case. So in this case, the earliest case is on 9th day, and count back the minimum incubation period. So in this case, the minimum incubation period is 2 days. So if you count backwards from that, 8 and 7. So note down the date 7th. And now coming to the last step, identify the last case. So in this, the last case is on 13th, and count back the maximum incubation period. In our example, the maximum incubation period is of 10 days. So you subtract 10 from 13, so it will be on the 3rd day. Coming to the result section, now how you will identify the most likely period of exposure based on this data. So the range of dates identified in step 3 to 4 represent the most likely period of exposure. So in our example, in the step 2 we got the date 6th, in step 3 we got 7th, and in step 4 we got 3rd. So the most likely period of exposure for this outbreak is from December 3rd to 7th, that is step 3 to 4. And if the 3 dates are widely separated, these 3 dates like step 2, step 3 and step 4, this indicates the incubation period has a wide range, or the outbreak is not a point source outbreak, because in point source outbreak, the exposure is brief and all the cases fall within one incubation period. So let's see all the 3 in a single frame. So initially we start from the peak, we identify the peak was on 10th day, and from peak we go backwards towards the average incubation period. And next you identify the earliest case, that is on 9th, and you go backwards till minimum incubation period. And then in the last step, you identify the last case, that is on 13th, and you go back till the maximum incubation period. So the most likely period of exposure here is between 3 and 7th. Thank you.